Okay, to catch the people up who are watching this video, today is a review day, and we're solving complicated trig equations. So the first one we started with was the red one there, and it was sine squared, and so a student suggested we take the square root of both sides, so we did. And then we got the absolute value. Hardest thing, I think, for most kids, because they don't know that when you square root a variable, you get absolute value. Then the square root of 1/4 is the square root of 1 over the square root of 4. So it was 1/2. And then we have two equations, these two. And then this one, sine is positive. I have this little thing we do, ASTC, all students take calc, and that says all of them are positive in the first quadrant, so that's one place. And sine is also positive over here, which is the other place. So it can't be here, can't be here. And now sine is opposite over hypotenuse, and what's across from the 1? That's a 30-degree angle, aka pi over 6. And then I'm going to go around to that one, which is a bunch of pi over 6s. 5 pi over 6s. Raise your hand if you had 1 pi over 6 and 5 pi over 6. Awesome. But wait, there's more. And since these are the places where sine is negative, I know it's going to be these two quadrants. And I know this is all about pi over 6s. And so I'm just going to take a leap and say that's going to be 6 pi over 6. Okay, because this angle right there is a pi over 6, also known as a 30-degree angle. Okay, if that's too fast for you, I'll go like this. Opposite hypotenuse, square root of 3 goes here. It's negative. The most common mistake in circle trig is to forget that negative. And then 6 pi over 6 would be not quite far enough, so this is 7 pi over 6. Sorry about that. And then this goes further to this one, which is 11 pi over 6s. Does that make sense? All right, now that innocuous little red problem had 4 answers. How could we possibly have 6 answers? I'll show you. Let's imagine a problem where we have sine of 3 theta is equal to 1/2. Now there's 3 ways I can do this problem. The first way is I can say, no rules, just solve. Well, then there's an infinite number of answers. Why? Because sine is a wave going back and forth and back and forth and back and forth. And y equals 1/2 is the other thing. And if you graph them both, y equals 1/2 is like here, and sine is like here, and it's going to just keep on touching it over and over and over and over, right? So if that's the case, you would want to find the 2 answers like we normally do in circle trig, and then add plus 2 pi k. So I'd like to do that. I'd like to say I didn't specify, and therefore you're supposed to find all of the answers. Well, my first step would be to make this u. We did a let u equal 3 theta, and now sine of u equals 1/2, and I just did that one a second ago. I've got a short-term memory. It was right there. And the answers are pi over 6 and 5 pi over 6. No reason to have to do it all over again. So u equals pi over 6 and 5 pi over 6. Are you with me so far? Okay, now we swap out the u for a 3 theta because that's what u is. And this is a really important moment. Now I've got to put plus 2 pi k right here. Why? Because in its original form, our problem that had the u in it, not really the original form, but the problem that had the u in it, the period is 2 pi. So 2 pi k? K means you can do it, it's a constant. You can do it any number of times. You can add 2 pi once, you can add 2 pi twice, you can add 2 pi 1,000 times. All right, so why do I need that here right now? Because I'm about to now multiply everything by 1/3, including that and that. The reason we can't just leave it as plus 2 pi k is because this period, for this function, the blue one, the one with the 3 in the middle of it, that one's period isn't 2 pi. It's 2 pi over 3. And now, here's my answer. Pi over 18 is one of my answers. And this one, 5 pi over 18, is one of my answers. And then if I wanted to get all the rest, I'd have to add 2 pi k over 3 plus 2 pi k over 3. Now, how would this be different if I said I want all the answers between 0 to 2 pi? And usually what we do is say it can be 0, but it can't be 2 pi. It can go right up to 2 pi, but it can't be 2 pi because that's the same thing as 0 in the circle trig world. All right, so if I wanted all these answers, would this be between 0 and 2 pi? Yeah. Would this be between 0 and 2 pi? Yeah. Could I add this to this, and would it still be between 0 and 2 pi? Yes. And in fact, somebody smart's going to know how many answers are there again? 6, because there would have been 2 if this didn't have the 3 here, and then there's 3 times as many. So 3 times 2, 6 answers. Would you please find all 6 answers? The first 2 are the green ones. Find all 6 answers. Get a common denominator, pro tip, so that isn't adding 2 pi k over 3. Make it over 18 by getting a common denominator. All right, in a moment, I'm going to ask you to compare all 6 answers with the kid next to you, and I'd like you to put them in order, and I'd like you to leave them in pi over 18ths. I know they can reduce, but it's much cleaner to say like 1 pi over 18, 5 pi over 18, 10 pi over 18, 15 pi over 18, you know, that kind of thing. All right, so I'd like them all to be over 18, and I'd like you to put them in order, and there's 6 of them, and then I'm going to ask you to compare with the kid next to you. Yes?
Would K be 6?
K can be anything you want. You can put in a 1. Here, let me show you what I mean. If I put in a 1 right here, do you get we're going to add 2 pi over 3? Because 1 times it means it's 2 pi over 3. Or I could put in a 2 here, and then I'm going to add 2 times 2 pi over 3 to it. And then I can put in a 3, and I can put in a 4. But if I put in a 6, then it'll go past 2 pi. It'll be too big. You can't just keep adding this forever because it'll get too big. The answers can't be bigger than 2 pi. All right, so my first answer in my list was pi over 18. The second answer in my list is 5 pi over 18. Those are the first 2 I found. And then you add this and you get the next answer, and you need a total of 6 of them. How many of you are already done? All right, and that's about a third of the class. I'm going to pause for a bit, let kids get caught up. I would have been thinking about getting this to be 18th, so I'd be multiplying by 6 here and 6 here. So this is really 12 pi over 18. Same here. 12 pi over 18. They're equal, but so much easier to add. All right, so if I'm going to add 12 pi over 18 to the pi, then I'm going to get 13 pi over 18, and that will be my next one. And then I'm going to add these 2, and I'll get 17 pi over 18. And then I'm going to do it one more time. It's like k just turned into 2. I'm going to add 24 pi over 18 to the 1 pi, and that makes 25 pi over 18. Another way to say it is I could add 12 pi over 18 twice. You know, I already added 12 pi over 18 and I got that. I'm going to add another 12 pi over 18 and then I get 25 pi over 18. All right, and then the last one is add 12 pi over 18 again. And I had 17 pi over 18, add another 12 pi over 18, and that makes 29 pi over 18. And I believe I have got my 6 answers. Raise your hand if you had the same thing as I did. Awesome. Okay. So there's 3 ways I can ask the question. I can say cosine of 4 theta equals negative root 3 over 2. And I could say I want all the answers, which seems like a lot, but it's actually the easiest. Because you just get the 2 answers from circle trig, and you say plus 2 pi k. Except you got to adjust for the period. Because this one's period isn't 2 pi, is it? Okay. Or I could ask for all the answers between 0 and 2 pi. Okay, or if I don't say anything, you'd have to figure out what I meant. And if it just says solve, it's okay with me if you ask me if it's on a test, which I mean, okay? But the test should say, because if it doesn't say, then you should probably default to the one where you add plus 2 pi k. Okay? All right. Let's try this last one, and I feel like you've got it. I'm going to default to, if I don't say anything, you can't assume that I want it between 0 and 2 pi. So give me all the answers. Which doesn't mean 8 answers. That would technically be a limited number of answers. I want the one where you're going to say plus something at the end. All right, pausing. Give it a shot. Agreed. Change that to a U. Then what? Okay, circle trig. And where should cosine be considering it's negative 3 over 2?
It could be in either of the left two.
Okay, excellent. Can't be here, can't be here. So right here, cosine is adjacent for hypotenuse. And then it's a 1 right here. And then what's across from the 1 is a 30. So then it's a bunch of pi over 6s. That would be 5 pi over 6. Raise your hand if you had 5 pi over 6 as part of your answer. Okay, good. And then the other part is down here, which would be, say, 7 pi over 6. And then it's u equals 5 pi over 6. And u equals 7 pi over 6. But you're far from done. Take it over from there, Isaac. Because we had let u equal 4 theta, you now are replacing this with a 4 theta. I agree. Then what? This is an important part. See if you remember something important.
I added 2 pi k.
2 pi k. Nice. But wait, some kid might say, this thing's period is not 2 pi.
Oh, then you divide everything by 4.
Yes. And I now have got my answers. And actually, it's kind of nice. That is it. You don't have to rewrite it from there. Yes, you could reduce those things, and you should. It's my official line for tests. You should always reduce. But especially if you're going to give me one of those answers where you've got like 5 answers, leave them in the same units like pi over 16s or whatever. 5 pi over 16, 7 pi over 16. So these are all in 24ths. So 5 pi over 24 and 7 pi over 24. Either one of those reduces. Technically that could reduce, but just leave it. On the test, reduce it. Okay, so I feel like we've covered most things, but let me give you just one last. Remember the goal here is solving. It's not just doing inverse trig. And there's those inverse trig restrictions, and then there's solving. And let's see if I can get one that you might be able to sink your teeth into. That is a solve question. I'll pause for a second. What do you think about that? Okay, how many of you see it? Two people see it. If I've got this many really smart kids stuck, then I know what it is automatically. Don't you know what it is automatically? If you can factor it, you should. This can factor. Tyler, is that what you thought?
Oh, I tried to do your substitution.
Ah, yeah, but then you would have had to factor it. You're right. You could be sine theta, but then the point is to factor it at the end. So this is going to be sine and sine. And then how do you make, oh wait, I always do the signs next, so to speak. The thing like plus and minus, you know. This has to be a plus and a minus. It has to be. Like you can know that because this one's negative. And this one's positive, you have to be using 1 plus and 1 minus. And then last but not least, it has to multiply to 3, or negative 3 to be exact. So then it must be a 1 and a 3. Now this one, sine of theta plus 3 needs to equal 0. So sine of theta needs to equal negative 3. Why do I stop right there? Can sine ever go to negative 3? Can regular sine ever be negative 3? No, it's the lowest it can ever be. So that's out. No solution. That's extraneous. And I go over to this one. Sine of theta minus 1 equals 0. So I'm going to add 1 to both sides. I get sine of theta equals 1. And that is a thing. Sine equals 1. And you might be like, but you can't have a hypotenuse. It's the same as... You're forgetting about the quadrantals. Sine of theta equals 1. Solve. Think circle trig. Question, Ms. N.
I think people that there's a 4 instead of that sine theta. How wouldn't it be like sine squared theta and then minus and then plus 2 sine theta?
Uh-oh, did I factor wrong? Check. Ah, crap. Yep, I factored wrong. Okay, sorry, in my head, 3 times 1, they would both have to be positive. This would have to be a plus right here. So I apologize. You're right. And this would have to be a plus right here. And then this will have to be a sine theta equals negative 1. But I still want you to solve it. Thank you for catching that. I made a problem that I thought for sure factored. Didn't. They changed the sign. It factored. And you ended up with this, though. And I'm concerned because we haven't done a quadrantal in so long. These are the kind where you can't draw the triangle for it. That means the answer is at one of these spots. Or maybe 2 of these spots. How many of you already know where this is? Okay. For the rest of you, sine is y, cosine is x, and tangent is y over x. So I think unit circle. Try to answer it with what I just said. So this is 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. And the last one here is 0 comma negative 1. Okay. So where is y? Sine is y, right? Where is y negative 1? That's the only spot where y is negative 1. So this answer is 3 pi over 2, unless we were doing, what's that kind of trig we started this whole unit with? Inverse trig. Did it ever say inverse anywhere on this problem? No, it never said to the negative 1 power. It never said arc anything. And so this is good. It's okay to use 3 pi over 2. And that brings up inverse trig. So we should probably talk about that. So final answer for this one was just one answer. That's the only place where sine is negative 1. At least between 0 and 2 pi. Okay, so theta was equal to that. Last but not least, what are all those restrictions? One thing goes from here to here. One thing goes from here to here and doesn't touch. One thing goes from here to here and does touch. Then there's 2 of these quadrants that are special. Tell me anything else you can remember about these kind of questions. So make those restrictions and then solve this. Pausing. Here we go. The restrictions. This is the only place that inverse cosine can be. So only the first quadrant and the second quadrant. Okay, the green one is where inverse sine can be. And the blue one is where inverse tan can be, and that one doesn't touch because of the asymptotes on both sides of inverse tangent. Okay, then this guy gets rewritten as cosine of some angle is equal to 1/2. But it only can be in the upper two quadrants. That's the big but. See, this would normally have two answers. But because it's inverse trig, there's always only one answer. So then it goes over here because it's positive. Adjacent hypotenuse square root of 3. What's across from square root of 3? Pi over 3. So there's my answer. Remember, these are always about getting an angle. The answer to that is an angle, and it's pi over 3. Can we make those more complicated? Sure. I can throw in x's and all kinds of things. So, and I don't want to take up all of our time today. So that's a good enough review, I think, of everything we've talked about so far. And honestly, I kind of wish we were just testing tomorrow, but there is a little bit of new stuff that we will throw in after break, and we'll review, and then we'll test. Okay? All right. You have homework. It's the same homework as yesterday. I know a lot of you didn't do much of it. Do a few more problems in there. And the rest of this hour, I want you to be either A, working on the lab, B, working on any old homework that's missing. If you look in your grade book right now, I go and put in a 0. One last thing we can talk about on the zeros is if there's a 0 in the grade book, it's really simple. It's late. And that's why I put the 0 in. And a lot of times kids are like, I turned in this assignment and I don't know why it says 0 there. It's because when it was late, I went and put a 0 in. And yeah, you've turned it in since then, and I will put those in. I would appreciate it if you don't email me about assignments that you've turned in. I know some people actually want you to. I don't need you to, because think about this. If all of you turn in one late assignment, I have to deal with 33 emails. Okay, just to turn in your assignment. So I'll do it. I always do. I look through the grade book and I can see it like tells me this person has put in a new thing, and then I know, and I can, you know, the Schoology will tell me that. So you don't need to send me an email every time you turn in late stuff. And the reason there's a 0 there is because it was late. I never put in a 0 before it's due. I wait till after it's already due and it's late, and then I put the zeros in to remind you, hey, this is missing. Okay, so if there's ever a 0, that's why. Okay, and that's all I have for the video for today.